Alright, so when you're on an assessment or you're going in for the install, like Steve was talking about, you're just going to make sure that the motors are actually shaded pole. So if there's a disconnect switch, you're just going to make sure that it goes to a stop and it doesn't hesitate and wiggle. So this one, when it stops, is EC. It's going to shake back and forth. This one's going to coast to a stop, and then as well on startup, this one's going to pause, this one's going to start up right away. So this is shaded pole, this is EC. If you're going to be doing the install, best practice is to turn off the compressor. As you get quicker at it, if you're doing a bay like this of just two in a coil, probably could just leave the compressor on. It's going to get a little bit of frost, but if you're quick enough, that's not really going to be a big deal. But best case, just turn the compressor off every time, especially when you first start out, in case you run into some issues. So we're going to be replacing this one. I already have an Azure blue motor in the left-hand slot here, so we're going to be replacing this. Typically, most of what you're going to into is going to be a 1/2 inch on the outer nuts, and the motor's going to be held in by 3/8 inch nuts. So we're going to go ahead and take our cover off. Now, if I was in the field, I would have my ladder set up in between these so that I could take both covers off, both fan blades off, both motors out. So I wouldn't be swapping out tools as I was moving along. In this case, we're just doing the one, so we're going to go ahead and take our cover off. Take our fan blade out. Our fan blade is typically a 1/8 inch Allen wrench in the set screw. I carry around a set of standard and metric just because sometimes it's metric or a size bigger or smaller. But 95% of what you're doing is going to be 1/8 inch. We're going to loosen that up and take our blade out. On the inside, we're going to take our motor out. Like I said, these are typically 3/8. Right now I have 5/16 in. That's what comes as the replacement nuts on the backside of the Azure motors. If you want to use the 3/8 that are in there, that's fine. Those will also fit on the Azure motor. So we're going to go ahead and disconnect our motor, and we're going to take our nuts off the front of the motor here. One of the things to be careful for as you take this out, so this is a trainer. If you want to look up inside, you can see that the back coil has been beat up just from the motors being taken in and out so often. Each one of those nicks here is going to reduce efficiency on this motor. So you want to make sure that that happens as little as possible. You can try and flatten them back out with a flathead or something, but basically that stops airflow and it's going to reduce efficiency because there's less surface area to absorb heat from the cooler. So try and avoid that as much as you can. This is a fairly shallow coil. Sometimes the coils are wider, and this is a lot wider than, say, something like this. So you can see that that's almost an extra inch of space. So what you can do is cut the studs off of the backside so that this is more similar. So that's still bigger, but it might be a little bit easier to get that to fit. The reason that they put those on the back is because occasionally a shaded pole motor will have L brackets mounted on the outside, and it'll be mounted in the unit like this. So in those cases, Azure makes this triangle bracket, which attaches to the back side of the motor so that you can install it in those applications. Those are rare. We usually carry about 6 of these around in our truck just in case we run into something like that, because that's hard to see on an assessment. But that's why the studs are on the back. In this case, we don't have to worry about that. So we're going to take our motor and we're going to install it. When you install these or the orange motors, both have a label on the underside that says mount drain hole down. What they're talking about is these weeping holes here and here. When you install these motors, you just want to be aware that that is facing downward so that it can drain. You want to be as close to straight up and down as you can. I usually tell my installers at least in between the two bottom legs of the cage, so anywhere in that bottom area. So as we're putting it in, again, we're just going to be cognizant to try and not damage our coil. We're going to stick our shaft through and then kind of tilt up. We're going to hold it in place, get our nuts started. Got that in. I'm going to take our cord and plug that in for our line voltage power. And in some cases, the motors will be direct wired in. In those cases, it is okay to cut this cord off and direct wire it in. But obviously, for efficiency reasons, if you can leave it attached, that would be the best case. Then what we would do, I already had this drilled, but we would drill a 7/8 inch hole here for our low voltage wiring. We usually stick out one end for programming, and then you could run your thermistors out of the case through this hole. Otherwise, you could run your thermistors to your refrigeration lines inside your box through this side panel here. That's something that you'll have to decide as a company, but we drill this out and we take our thermistor kit. So we're going to feed that through our 7/8 inch hole here. Just being careful to go underneath our cage so that we don't catch any of our wiring in the fan area itself. So our thermistor wires get connected to the two black cables, our low voltage wiring that's coming off of our motor. It doesn't matter which is which. We're going to go ahead and connect those and make sure they're locked in place. Just give it a tug test to make sure that they're not going anywhere. If one of those were to disconnect, the motor is going to default to a high speed, so it's not the end of the world, but the customer will not get the savings from the 2-speed controller that they thought they were going to be. So on our motor, we have one male end connector and one female end connector off these blue and yellow wires. These are our daisy chain control wires. So this is our programming module. It has a female end on it. So what we do for programming purposes is we take our male end and we stick that through our 7/8 inch hole right there. And then we're going to take our female end and we're going to connect that to the low voltage wiring from my blue motor here. So I connected that there. The female off this one could be connected to the male off of the next one, as many as are in your coil, assuming it's 5 or less. Once you have all that connected, you're going to go ahead and take a plastic pass-through connector just to protect your low voltage wiring. Stick that there. Now we're going to take some zip ties just to make sure that none of our wiring is going to be hitting the fan blade. And we're going to try and zip tie that into the back of our unit. Side cutters and cut off the excess from the zip ties. Alright, so now I've got our motor installed, it's got power. If the disconnect switch is accessible, we can go ahead and make sure that it spins, which this one does, so it works. We're going to go ahead and put our fan blade on. So each of these shafts has one smooth side and one rounded edge. When you install the fan blade, you want to make sure that your set screw is lined up with the smooth side of the shaft. So we're going to install it like that. When you're putting it in, you just want to make sure that the fan blades, you can see the rounded edge poking out of the coil itself. So typically I tell my guys half in, half out is a good starting place. This coil is a little bit deeper set, so we don't have too much more shaft to work with, but somewhere around there is typically a good spot to start with. If it's too far in or too far out, you will hear a whistle. It'll be out of pitch, so all you have to do in that case is just readjust your fan blade to get it to a place where you do not hear that any longer. So once you find a spot that you like, you're going to just tighten down your set screw again on that flat side. You can tighten it down one time on the rounded side. Past that, the next person's probably not going to be able to get that off, and you're probably going to have to cut the shaft and buy a replacement fan blade. So once that's in, just make sure it's tight. We're going to put our cover back on. Now if you look at the back of this cover, you can see that there are two wider openings and two smaller openings. The reason for that is that this cage is held in by two flat nuts on the corners, and then there are two open bolts. So the flat nuts fit inside of the wider openings. If you were to line up the flat nuts on the shallower openings, your squirrel cage will be flexed. So we want to line those up, put it back in place. We're going to put our 1/2 inch nuts back on. So after we've installed and replaced our covers, we just want to make sure that we're not hitting any wiring. So what I always have my guys do is turn the motors on, let them spin for a second, just make sure you're not hearing anything, which we're not, so that's good. Now that we've done this, we are going to check for airflow. So in this case, I've got one that I can feel has air coming out of it. This one did not, but because this one is the master motor, it's going to change directions to copy what this one came from the factory set at. So because this one has the thermocouples connected, whatever this motor as the master motor is doing, all the subsequent Slade motors will follow suit with the master motor. So this was spinning in an opposite direction, but because this was programmed to spin clockwise, this also started spinning clockwise. So we're going to change that with our programmer. So we're going to take our female end, and we're going to plug that up here. Again, just locking it into place. We're going to go ahead and turn our programmer on. Then we're going to take our phone, and there is an app from the Azure store. So we're going to go onto the Azure app, we're going to click scan. When we click scan, it's going to show us a number chain there. That's basically the Bluetooth controller. So you're going to click on that. It's going to say that it's connected to the programmer. We're going to click connect the motor. It's going to ask us if we have thermocouples. That's our controller wires here, which we do, so we're going to say yes. Once that's done, it's going to show us our read options. Basically, that's what this is set to. So this is set to clockwise rotation, high speed 1550, low speed 800. So this is going to make the rest of the motors in the chain all have that same programming. So as an example, we're going to change that. I'm going to click program. We're going to make this spin the opposite direction. We're going to set our high speed to its maximum of 2000, and our low speed we're going to set to 600. That's the highest and the lowest it will let you go. You would never set a motor at those speeds, but just as an example, that's what we're going to set it at for now. So once we have that, we're going to click write parameters. Once that's done, you're going to see this motor slow down, stop, and change directions. Now that that's done, we're going to turn off our bay of motors. We're going to click disconnect the motor, turn off our controller and disconnect our controller. So now that we've turned it off and ran a power cycle, this motor with our thermistors on it has saved its programming. So now this runs counterclockwise with a high speed of 2,000 and a low speed of 600. Again, you would never set a motor like that in the field. 1,600 as a high speed and 1,000 as a low speed is what we recommend, but there is variation in what you could set it at. But for now, this one is going to spin counterclockwise. This one is still pre-programmed to the initial setting that this one had of the 1550 and 800 spinning clockwise. But when we turn it back on, because this has new programming saved, and again, this is a slave motor, it will change directions and follow what this motor is now programmed to. So as you can see on startup, this is spinning the opposite direction that this was. In a moment, this is going to slow down and change directions because this has new programming. So these are running at 600 RPM because our thermistors are the same temperature. So if I hold on to one of these thermistors, this is going to be warmer than this. It doesn't matter which is which, but the difference in temperature is going to tell our motors that they need to be in a higher speed. So right now it's very quiet. You'll hear it kick up in a second here. So again, because these are at different temperatures, this kicked into a higher speed. So you want to put these in a place that you can, the thermistors would be able to sense that based on the refrigeration cycle. So there are a few ways that you could do that. One of the ways that you could, which would you could show the difference in temperature, would be to stick one in the airflow coming out of the fan blade. So in this case, the refrigeration cycle turns on, the coil gets cold, that cold air is being blown across this thermistor here. Your other thermistor could just hang somewhere in the ambient temperature. So the ambient temperature is set to say 37. This one is going to be in that colder airstream that's 32, just that cool temperatured air. Once that difference happens, this is going to kick into a higher speed because these are now different temperatures. The other way that you could do it is you could have one still sitting somewhere in ambient temperature, getting your 37. You could stick the other one in the back of the coil, pressed up against one of the lines running through this back of the coil. So there are all these fins, and in between those fins there are the individual lines coming from the suction and discharge lines. You could press one of these up against that, and then one in the ambient air. Again, this is going to be colder than the ambient air is. The most accurate way you could do this would be to stick them directly on the suction and liquid lines, or on both sides of the TXV, which would be in this side panel. So this is what I was saying about running them across to this side panel. So each coil is going to have a padded copper line and an unpadded copper line going inside of it. So inside our side panel here, you can see we have a larger copper line down here and a smaller copper line here. So this would be padded as it came out and exited the cooler, and this would be unpadded. So these are going to be different temperatures. So one of the ways you could hook these up would be here and here. The other way that you could hook up your thermistors is you could hook these up on this side of the TXV and this side of the TXV. So you want to, not this regulator valve here. This is why this is typically a little bit more confusing as far as where to put these, but basically this one, as you can see here, is coming off of the top of the coil, and this one is discharging back to the compressor. So this is going to regulate the difference in temperature between the two of them, this part with this silver end on it. So if you put one of these here and one here, you're going to get the coldest temperature on this side and the warmest temperature here. When you're doing that, that is going to be immediately, as soon as the refrigeration cycle kicks on a big difference in temperature, because that's where that differential of temperature is happening. So it's going to put the least amount of stress on your compressor. The downside of that is that if you were to incorrectly hook these up, this is going to freeze and you're going to have a frozen coil. If you were to do your installation and leave this side panel off and strap these in, if you were to incorrectly strap it in and just wait 10 to 15 minutes on the job, you'll start to see this get cold and maybe a little bit of frost on it, which isn't a big deal if you catch it right away. So if that happens, you could just go ahead and clip your zip tie that's holding this in place, move it to where the frost is built up, and you'll be good to go. But it's just one of those things that you as a contractor will have to decide how you want to do it yourself. But this is about 90% of what you'll run into in the field. Like I said, there are variations with the side panels or the triangle brackets. Sometimes you'll have to cut the studs off the back. But this is 90% of what you'll be working with. Another note on the programmer. So this is for your 3.3 or your smooth shaft motors. This is for your watt motors. That's the screw shaft version that Mars makes. There's a little tab in the back that you pull out there, and this connects like that, and that's how you would program this motor. So this can't be controlled with thermistors like the other one can, but that's how you would change directions back and forth. But it's one controller that does both of those, and you keep this with you as you go from job to job.